Hello, I would like to discuss the requirements of Assignment 4. Assignment 4, you're going to be creating a proper engineering drawing of a guide bar modified. So I gave you a drawing of the guide bar, and the guide bar had a couple holes in the part, and what I want you to do is change some holes to modify the holes to add features to them that we learned in this lesson, namely a countersink and a counter bore. Okay, so part A says the leftmost hole must be designed to accept a flathead screw. McMaster-Carr part number 91253A014. Now, I gave you the page cutout here from McMaster-Carr, but you could also go look this up online. Just go to McMaster-Carr's website and type in that part number. What you're going to see is a screw with a flat head and an 82-degree countersink. Now, what I want to do is I want you to add a countersink to the part to allow us that screw to sit below flush. Now, if you remember how we dimensioned countersinks, we dimensioned them by, first of all, the angle of the countersink, which was this 82 degrees that we're talking about here, and then the breakout diameter across the top. So based on this catalog part number here, let me call this up. This screw that I'm talking about is a 1032 size screw, and I'm going to talk a little bit more about what that means, but that's actually the thread size. We're going to introduce that here, but it'll come up in another lesson. And then it's an 82 degrees by 411 thousandths. That's the head diameter. So what I want you to do is to dimension, add a counterbore feature to the guide bar at that leftmost hole that accepts this screw, and the screw sits below flush. Now, to do that, you have to make sure that the diameter of the countersink is dimensioned such that even at the minimum tolerance condition, the diameter of the countersink where it breaks out is going to be greater than this 0.411 inch. So that has to do with the first hole. Okay, it's a 1032 flathead screw, McMaster-Carr part number, with a head diameter of 0.411. The flathead screw must sit below flush. The through hole must be sized to provide a minimum countersink of 20 thousandths inch clearance to the maximum material condition of the fastener. The first thing I want to say about the fastener diameter is you have a 1032 screw, and with the 1032 screw, the diameter is 0.190. I'm going to show you that when I talk about this NAS part number next. And then the countersink surface must have a surface roughness of 32 microinch or better. That comes from the surface roughness section of this chapter. Next, the rightmost hole must be designed to accept another 1032 screw. This time it's a socket head cap screw. And here I give you the part number, NAS 1351-3-20. I gave you this specification in the assignment statement. Let's take a look at it. Okay, so here is that specification. What we're looking at here is a socket-headed cap screw, and the first number, that -3, that means that's this row right here. It's a 1032 size screw, and then this 0.1900, that is the maximum diameter of the screw. So what I'm saying in the assignment is that you need to make that hole 20 thousandths bigger than this diameter. The other thing I got to get from here too is we're going to put a countersink to make sure that this head is recessed below flush after it's installed. Okay, so I need to figure out the depth of the countersink, which is going to be enough to make sure that this head sits below flush. So the H dimension on that, we have a tolerance here. It's got a max dimension of 190 thousandths, and it's got a min dimension of 185 thousandths. So what I want you to do is to consider the maximum head of this screw and make sure that it fits within your counter. So you got to size the counter bore such that this screw head fits both diameter wise and depth. Okay, so the diameter of the screw you can find here with A. That is this head diameter, and here is the max and min diameters. So you need to have your counter bore, is what I'm saying. It has to be bigger than 312. So let's look at the assignment statement again. I am also asking for a washer to be put underneath the screw head. Okay? And I also gave you this specification there. And what you need to do is to make sure that the counter bore size is big enough to drop the washer all the way down into the bottom of the whole counter bore. Okay? And you also have to make the depth of the counter bore big enough to handle the height of the screw and the thickness of the washer. Okay? So I'm asking you to do a little bit of design work here. Not only do you have to design the countersink, not only do you have to represent the countersink and the counter bore on this new drawing I'm asking for, you have to figure out what these correct dimensions are to make sure that these specific parts I'm asking for will fit to the requirements. And when I say fit, I mean sit below flush in all tolerance conditions. And then finally, we have to have both edges of the lower surface. And I'm talking about the lower surface of the part. Look at the front view of the part. Okay, the lower surface of the front view of the part. That is the surface that I need the chamfers running the entire length of the part. Okay, and here's the size of the chamfer, and you know how to dimension those. And then I also want a surface finish roughness called out again on that lower surface. All of the dimensions have to be, again, like the tests and everything else, all the dimensions of the part have to be on there, specifically the way we talked about. And then here's how I'm going to score the drawing, and I'll send this to you too. I'm going to make this drawing worth 25 points. And since the lesson was on the features and the surface finish, these are the changed elements I'm asking for. I'm going to make this a little bit more, worth a little bit more points. So here's your typical dimension. Here's your presentation. Did you submit to me properly? It's got a title block and border. I can read it and all that other stuff. Projection means you give me enough views to make sure that I can represent the part properly. You're using the proper third angle projection. The size is proportional to the page, and it looks professional. Now, dimensioning, all of the features are dimensioned, and all of the features have tolerances as well. You can do that with a block tolerance note, or you can do that with a block tolerance. Some of you people have it built into your borders, and if you don't have it built into your border, you can either put a tolerance on every dimension you show in the field of the drawing, or you can add a note with a standard tolerance if you would like. And then finally 10 points for all of these elements that are properly changed. Okay, thank you. I hope this helps.